Hey, Scott Jordan here for Jancast number 209 for Thursday, March 19th, 2026. So I'm not currently in my office. I'm traveling around the United States a little bit, having some fun getting out of the cold weather in New Jersey. We had 18 inches of snow a couple weeks ago. So since I left, we have this war situation or whatever you want to call it over in the Middle East. And I thought, how can we compare what's going on with our current geopolitical situation as well as what went on back during the pandemic? Because they're both going to, we know what happened in the pandemic with the supply chain issues. We're not exactly sure what's going to happen this time. So with my AI assistant host, we kind of delve into the differences between the supply chain issues involved with the pandemic and the supply chain issues potentially with the geopolitical situation we have coming up. So I hope you find it interesting. I'll be back home in a week or so for the next show, which will be 2 weeks from now, the next new show. So I hope you enjoy this one and send me some feedback. I really appreciate it.
Let's start with a mental image. Picture a complex physical web, thousands of interconnected threads spanning the globe, moving materials from extraction to your local warehouse. Now watch what happens when an invisible pressure causes those threads to snap. That snapping point is where operations managers in the commercial cleaning industry are currently most vulnerable. Right now, entire supply networks are actively buffering their inventory based entirely on the lessons learned during the 2020 pandemic. To understand this problem, we have to look at the baseline of the cleaning industry. This is a sector heavily reliant on a continuous flow of highly specific chemical precursors navigating through global shipping lanes. Exactly. And here is the core issue. The mechanics of a pandemic supply chain failure are strictly inverse to those of a war-driven disruption. You cannot fight a new war with the previous war's tactics. This brings us to a concept you call disruption topology. Disruption topology is the framework for identifying the specific structural origin and geometric shape of a supply chain failure. Misdiagnosing that shape is a strategic mismatch, locking limited capital into empty warehouse capacity while production lines halt for a single missing chemical precursor. Look at this photograph of a massive petrochemical refinery. This heavy industrial site is the foundational tier of the industry. Before we get to sanitizers and floor waxes, we start here, extracting bedrock raw materials like petrochemicals and surfactants. Surfactants are chemical compounds that lower the surface tension between two liquids, allowing them to mix and clean effectively. From that foundational extraction, those bedrock materials enter the secondary manufacturing phase. This is where those raw inputs are chemically blended and processed into usable cleaning agents. We can see the next phase in this photograph of a bottling line. This is the final packaging phase, the exact moment where raw chemistry transitions into tangible, finished goods ready for the commercial market. The final step is entirely logistical. It's the global and domestic distribution network moving these finished bottles out of the factory and into commercial facilities, hospitals, and schools. A disruption at any single point in that chain causes a failure at the endpoint. But accurately diagnosing exactly where the chain broke dictates your entire survival strategy. Let's deconstruct the 2020 COVID-19 disruption. Structurally, we define the pandemic model explicitly as a demand shock. We can see the immediate symptom of a demand shock in this photograph of empty retail shelves with a sign limiting purchases to 6 per guest. This proves the extreme, anomalous spikes for sanitization products globally, which created a violent bullwhip effect. The bullwhip effect is a phenomenon where small fluctuations in retail demand cause progressively larger fluctuations in wholesale and manufacturing orders upstream. During that demand surge, the raw precursor materials still existed. The problem was transit. We see that bottleneck in this photograph of a choked container port. The physical transit capacity completely froze. That freeze triggered immense bidding wars. Distributors fought over limited shipping containers, scarce port space, and last-mile labor. Notice what was driving the price increases. The fundamental cost of the actual chemical liquid inside the bottles remained relatively stable. It was the rising cost of logistics that broke budgets. So the pandemic failure was a crisis of velocity. The system couldn't move existing volume fast enough. In that specific environment, hoarding finished goods was a highly rational response. Now we pivot to the geopolitical model. We define this structurally as a supply-side severance. This animated diagram compares the two models directly. In a geopolitical crisis, demand may remain completely flat or even drop due to broader economic contraction, while the physical input capacity simply vanishes. Watch the bottleneck locations. On the left panel, representing the pandemic, the system clogs at the logistics and port node. On the right panel, representing a geopolitical shock, the connection is completely severed right at the raw materials origin node. In a war scenario, the transit routes might be wide open, ships are ready to sail, but the upstream precursor chemicals from specific regions are heavily sanctioned, embargoed, or physically destroyed. That structural shift completely changes the pricing mechanics. Look at this photograph of heavy gas pipeline infrastructure. This grounds the abstract concept of pricing in physical energy constraints. War-driven pricing surges aren't dictated by bidding on shipping containers. They are dictated by energy inflation and true material scarcity, which structurally raises the absolute floor price of manufacturing. A geopolitical shock is a crisis of volume. Stockpiled shipping capacity and empty warehouse space are utterly useless if you have zero chemical inputs to manufacture the product in the first place. This directly challenges the current operational misconception out there, the aggressive, just-in-case buffering of finished commercial cleaning supplies. Hoarding final products depletes your vital operating capital. Worse, it provides zero protection against a long-term upstream ban on chemical inputs. You eventually run out of bottles, and you cannot make more. This requires a pivot to a strategy called deep-tier mapping. We can see how this works in this animated nodal graph representing an inventory buffer model. Instead of looking forward, we animate the perspective shifting past the Tier 1 warehouse, where the finished goods sit, and plunge backward into the network, isolating the Tier 2 and Tier 3 chemical suppliers. Down at that level, you find specific, highly vulnerable single-source ingredients buried deep within the formulation tree. Notice how they flash red here. These are your critical failure points. Securing alternate global sourcing for those highly specific Tier 3 inputs before a conflict escalates is the only way to survive a supply-side severance. In a war economy, operational resilience shifts entirely away from owning physical warehouse space toward possessing deep upstream supply diversification. This 2x2 resilience matrix merges both models. The vertical axis plots shock type, demand versus supply. The horizontal tracks operational pivot, logistics versus precursors. The COVID-19 response plots here, matching logistical agility with stockpiling. The geopolitical response plots opposite, requiring supplier diversification and chemical reformulation. That need for reformulation introduces the highest level structural opportunity for manufacturers: modular product formulations. Modular formulation is the engineering practice of designing product recipes so that specific raw ingredients can be safely swapped without altering the final performance. Manufacturers who engineer their cleaning products so that scarce chemical precursors can be rapidly swapped out, like in this mixing chamber, will absolutely dominate the market. Compare that agility to competitors who are simply hoarding static inventory, burning capital, and waiting for a geopolitical disruption to magically pass. Structural resilience comes from the capability to diagnose the specific topology of a crisis and adapt the product's chemical makeup to the available supply.